Now, let us know about the difference between the acceleration due to gravity and the gravitational constant. We know the acceleration due to gravity is the acceleration produced in a body falling freely under the action of gravitation pull of the earth. But the gravitational constant is the gravitational force between the two bodies of unit masses separated by a unit distance. Next, the value of G is different at different points on the earth, but the value of capital G is same at every point on the earth. Next, the value of G decreases as we go above or below the surface of the earth, but the value of gravitational constant does not change with height or depth from the surface of the earth. Next, the value of acceleration due to gravity at the center of the earth is 0, but the value of gravitational constant is not 0 at the center of the earth or anywhere else. Next, the value of acceleration due to gravity on the surface of the earth is 9.8 meter per second square, but the value of gravitational constant is 6.67 into 10 to the power of minus 11 Newton meter square per kg square throughout the universe. Next, let us know about the motion of objects under the influence of the gravitational force of the earth. We know the equation of motion of a body with uniform acceleration in straight line are v is equal to u plus at, s is equal to ut plus half at square, and v square minus u square is equal to 2as. When any body falls freely under the gravitational force of the earth, then a is equal to small letter g. Therefore, the equation of motion of the freely falling body are given by v is equal to u plus gt, s is equal to ut plus half gt square, and v square minus u square is equal to 2gs. Next, let us know about sign convention. The value of g is taken as minus 9.8 meter per second square or minus 10 meter per second square whether body goes up or falls down, because g always acts downward. Next, distance measured upward from the point of projection is taken as positive, while distance measured downward from the point of projection is taken as negative. And the next, the velocity measured away from the surface of the earth is taken as positive, while the velocity measured towards the surface of the earth is taken as negative. Next, let us know about the mass of a body. The mass of a body can be defined as the quantity of matter contained in the body. The next is weight. The force with which the body is attracted towards the center of the earth is called weight, or the force of Earth's gravity acting on the body is called weight, and it is denoted by the symbol W. And the SI unit of weight is Newton. It is denoted by the symbol capital N. Now, let us know the difference between the mass and weight. The mass is nothing but the quantity of matter contained in a body, but the weight is the force with which the earth attracts a body towards its center. Next, the mass of a body remains constant, but the weight of a body changes from place to place. Next, mass of a body is never zero, but weight of a body at the center of the earth is 0. Next, mass is a scalar quantity, but weight is a vector quantity. And next, The SI unit of mass is kg and the SI unit of weight is Newton. So these are the differences between mass and weight of a body. Now let us solve the problems based on free fall under gravity and weight of body. You know, gravity is the phenomenon of attraction between Earth and any other body. The force of gravity is given by F is equal to capital G small m into capital M by r square. The force of gravity is also equal to m into g. Here capital M represents the mass of the earth and small m represent mass of the body and small r represent distance of the body from the center of the earth and g represents acceleration due to gravity. Next, the relation between small g and capital G is small g is equal to capital G into capital M by r squared. On the surface of earth R, near the surface of earth, small r is equal to capital R, that is equal to radius of earth. Therefore, G is equal to capital G into capital M by capital R square. The value of acceleration due to gravity is maximum at poles and minimum at equator and 0 at the center of the earth. Next, the equations of motion of freely falling bodies are V is equal to U plus GT, H is equal to UT plus half GT square and V square minus U square is equal to 2GH. First problem, calculate the force of gravity acting on your friend of mass 60 kg. Given mass of earth is equal to 6 into 10 to the power of 24 kg and radius of earth is equal to 6.4 into 10 to the power of 6 meter. Let m is equal to 60 kg and the mass of the earth is denoted by capital M is equal to 6 into 10 to the power of 24 kg and radius of the earth capital R is equal to 6.4 into 10 to the power of 6 meter and gravitational constant we know 6.67 into 10 to the power of minus 11 Newton meter square per kg square. Then we have to find out the force F. We know F is equal to capital G into capital M into small m by capital R squared. Substitute for G. G is equal to 6.67 into 10 to the power of minus 11 into capital M is 6 into 10 to the power of 24 and small m is 60 kg. And then R is 6.4 into 10 to the power of 6 whole square. Next, 6.67 into 6 into 60, 360 into 10 to the power of minus 11 into 10 to the power of 24 is 10 to the power of 13 by 6.4 into 6.4 into 10 to the power of 12. Next, multiply 6.67 into 360, you will get 2401.2 by 6.4 into 6.4 is 40.96. Now divide 2401.2 by 40.92, you will get 58.6 into 10. Next, 58.6 into 10 is equal to 586 Newton. Therefore, the force of gravity acting on our friend of mass 60 kg is 586 Newton. Therefore, the force of gravity is 586 Newton. Next question. A particle thrown up vertically with a velocity of 50 meters per second, what will be its velocity at the highest point of the journey? How high would the particle rise? What time would it take to reach the highest point? Here, the initial velocity u is given. U is equal to 50 meter per second, and the acceleration due to gravity g is equal to 10 meter per second square. We have to find out the final velocity and then h and then the time. When a particle is thrown up vertically, then its velocity becomes 0 at the highest point of the journey. Therefore, final velocity of the particle is 0. Next, from v square minus u square is equal to 2gh, v square minus u square is equal to 2gh, we can find out the value of h. V we know that is 0, and then u is 50 whole square is equal to 2, g is 10 into h. So minus 50 square is 2500. Since the force of gravity is acting downwards, it will be considered as minus. Therefore, g is minus 10. 2500 is equal to minus 20h. So, h is equal to 2500 by 20. We can cancel this 0. Then divide 250 by 2. It divides 125 times. Therefore, h is equal to 125 meter. And next, we have to find out the time by using v is equal to u plus gt. V is 0 and u is 50 and g is minus 10 into t. Next, by using v is equal to u plus gt, we can find out the value of t. V is 0 and u is 50 and g is minus 10 into t. So 0 is equal to 50, minus 10 into t is minus 10t. Then take minus 10t to left hand side. Then 10t is equal to 50. Therefore t is equal to 50 by 10. Therefore t is equal to 5 seconds. Next problem. A force of 2 kg weight acts on a body of mass 4.9 kg. Calculate its acceleration. Here F is given. F is 2 kg weight. You know 1 kg weight is equal to 9.8 Newton. So 2 into 9.8 Newton, and the mass M is given 4.9 kg, and then find out the acceleration A. Now using F is equal to ma, we can find out the acceleration. So A is equal to F by m, we can write. Now substitute for m. F is 2 into 9.8 and mass is 4.9. 4.9 ones are 2s are. So 2 2s are 4. So the acceleration is 4 meter per second squared. Next question. A man weighs 600 Newton on the earth. What is its mass? Consider G is equal to 10 meter per second square. If you were taken on moon, its weight would be 100 Newton. What is its mass on the moon? And what is acceleration due to gravity on the moon? Here, the weight of the man on the earth is WE is 600 Newton, and the weight of the man on the moon is given WM, that is 100 Newton, and the acceleration due to gravity on the earth is 10 meter per second square. We have to find out the mass and also the acceleration due to gravity on the moon. We know weight is equal to mass into acceleration due to gravity. So WE is equal to M into GE. So M is equal to WE by GE. W, the weight on the earth is 600 and acceleration due to gravity on the earth is 10. So the mass is 60 kg. And the next, we have to find out the mass on the moon. The mass of the object does not change. Therefore, the mass on the moon is equal to mass on earth. The mass on the moon is equal to mass on the earth. Therefore, the mass of the man on the moon is 60 kg. And the next one, we have to find out the acceleration due to gravity on the moon. Since the weight on the moon is equal to mass into acceleration due to gravity on the moon, then Gm is equal to weight on the moon by mass. Weight on the moon is 100 and the mass is 60. Cancel the 0 and then divide 10 by 6. We will get 1.67 meter per second square. Therefore, the acceleration due to gravity on the moon is 1.67 meter per second square. Next question. Suppose a planet exists whose mass and radius both are half of those of Earth. Calculate the acceleration due to gravity on the surface of this planet. Here, let the mass of the planet is equal to half of the mass of the Earth. Let mass of the planet MP is equal to half of the mass of the Earth, and the radius of the planet is equal to half of the radius of the Earth. So if RP is equal to half of the RE, then we can write RE by RP, RE by RP is equal to 2. Next, we know GE is equal to, we know acceleration due to gravity on the earth is equal to capital G into mass of the earth by radius of the earth. Consider this as equation 1. And acceleration due to gravity on the planet is given by GP is equal to capital G into mass of the planet by radius of the planet, RP square. Consider this as equation 2. Now divide equation 2 by 1. Now divide equation 2 by 1. We get GP by GE. GP by GE is equal to, GP is GMP by RP square into RE square by G into mass of the earth. We can cancel this G, then GP by GE is equal to mass of the planet by mass of the earth into, we can write RE by RP whole square. Then mass of the planet is half of the mass of the earth, so we can substitute half mass of the earth in place of mass of the planet by mass of the earth into RE by RP is nothing but 2 square. Here we can cancel this ME, then half into 2 square is 4. 2 2s are, therefore GP by GE is equal to 2. Then GP is equal to GE into 2. So GP is equal to, we know the acceleration due to gravity and the earth, that is 9.8 into 2. So the acceleration due to gravity on the planet is 19.6 meter per second square.